Welcome back to another video. So this will be regarding SolidWorks Klein Bottle design. As you can see, this will be the output model. This will be a solid body. That means if I will go within section, I will have thickness, and we see this self-intersecting bottle design. Now, I did the same over here as you can see within CATIA, within General Tissue Design, and I want to recreate this bottle within SolidWorks. And as you can see, the Klein bottle is an example of a non-orientable surface. And this way it's really interesting to have this 3D design. We see that this bottle was first described in 1882 by Felix Klein, as you can see over here. Now, let's get started within SolidWorks. I will create a new part. If you don't have the surface tab over here enabled, you can right click, go to tab and have this enabled. Now within this new part, I will start from the front plane and I will define a new sketch over here. Initially, I will use a center line in order to define the length of the main body. So I will have this dimension to 200 millimeters. And I will now define that profile. To do that, I will use a spline tool. As you can see on the spline, if I will leave the mouse cursor, we can define different control points, and afterwards we can change those tangencies using those arrows. Now, for this profile, I will just define a simple spline, so one point on the top, one on the bottom, and afterwards I will press escape. We don't need to define 3 points in this case. We can do that. For example, I can define a profile like this, and afterwards we can change this around, but I will just use this one with 2 points. So one on the top, one on the bottom. If you're going to select the spline, you're going to see that underneath it you will have this for rotation, we're going to have an arrow, and we're going to have a point. If I will select the point, for example, we can see that we can define that profile of the bottle. So if I want it to be like this, or like this, with an upper body, more defined than on the bottom. We have the same over here on the bottom, so this point. And in this case, I will select the arrow head over here. As you can see, I don't have the head relation to be horizontal, but if I will click on this one, that will appear. And now if I'm going to click on the arrow, that will appear as well. So I will just make this horizontal, and we see how that profile will be defined. I can also define the length of this arrow. So for example, 300. That will also change the profile over here a bit. So if I will go with a value, for example, 50, it will be really narrow. This is why we leave it like this. And over here on the top, we can add an angle. So starting from the point over here to the axis, I can define an angle. I will make this to be 50. I will better position that in the viewport. And now I can also use a smart dimension to define the length over here. And I will add a length of 250, as you can see over here. So this will be the profile of the main body. Now we only need a section of this spline. So for example, this section where I have the mouse cursor. Therefore, I will use 2 lines over here. I could have gone directly with the center line, but I will just create those 2 lines. And afterwards, I want this to be fully defined. So I'm going to add a value over here. For example, 30. This will be the top section. I will just move this over here so they are not overlapping. And over here on the bottom, I will add 45. Now, I will make all of this to be for construction. So I will select those by holding down Control, and I will click for construction option over here. I will leave this sketch because I defined this sketch just as a reference, and now I will define a new sketch in order to trace this spline over here. So go within front plane, define a new sketch, I will click on this and I will use the convert tool. As you can see, I added W to quickly convert that. And now I want to trim only to have this spline from this point all the way over here. To do that, I will also have to convert those two lines. And now I will use the trim tool, trim entities, trim closest. So I want to trim the top section, afterwards this as well. It's important with the order. For example, if I will trim this first and afterwards this will trim everything. So keep that in mind. So I press Ctrl Z and I will trim this section first and afterwards the line. Now we can leave the sketch and this will be the profile of the Klein Bottle. I will go within surface, revolve surface, and I need to define the axis. The axis will be that one. And I will click OK with a value of 360, so this will be the profile. To make this better looking within the viewport, I will enable the plain white over here. As you can see, this will give us the following highlight over there and a much better defined shadow on the bottom. Now I can hide sketch 1 and this will be the reference for the main body. I can also press F2 to rename this sketch dimensions, because I know that that will control the main profile. And I will go within front plane and I will define a new sketch, and we're going to start working on that handle profile on the top. So I will use a 3-point arc. I will start the first point to be over here, the second point on the same horizontal axis, and I will go with the third point over here where those three will be on the same horizontal. If you're just going to define one like this randomly, you can afterwards hold down Control and add a horizontal constraint between those. For the last point over here, I will make this to be vertical with the origin over here with the main axis. I will add a value, for example, 50. And now I can also specify the height of this section. For example, I want this to be at 30 millimeters above. And now I want to define that profile over here that will self-intersect the main body of the Klein Bottle. I will use the same technique with a spline tool as previously. So I will define an endpoint over here and one somewhere over here where we're going to have that axis. And afterwards I will press Escape to leave that spline command. Now I can select the spline over here, I can select the arrow, and if I will make this to be vertical, we're going to see how the orientation will be like that. I can also add manual tangency by holding down Control. I will select the first one, the second one, and I will add the tangency over here. I will select the last point over here and I will make this to be vertical. And now we can specify another value over here. I want this to be again at 30 millimeters above that. I will just slightly adjust those so they are better visible. And we still have that not fully defined, so I can define this curvature. For example, with a value of 350, the profile will go over here and intersect over here. And with a smaller value, for example 150, this will intersect over here, so somewhere along the middle of that profile. Now we can leave this sketch and we can define that swept profile directly within surface using the swept surface command. We're going to have the profile and path to be the circular profile. I will select the path, and over here for the value I will go with a value of 30, and this will give us the following output over here. We see over here that where this will end, this will be at an angle. So if I should adjust that, because over here on the bottom we need to have those just like over here. So the bottom section with this one should be parallel. Therefore I will go within that sketch, and over here for this arrow, so select the spline, select the arrow. Let's see, I should be able to add over here that vertical. I will just leave that sketch so we have that defined. And let's say again, if I will select that, I should be able to add a relationship. As you can see in this case, it will not allow me. I will just slightly delete that for now, and I will select this one. Since this is within that feature, we see the relation over here, but as soon as I will release it, it will no longer be active. So I will just deactivate the swept. So I will suppress that. I will go over here. And now we see that I can start working with this. So keep that in mind if you encounter this. You can just suppress the feature because the software is trying to have that updated. I'm going to make this vertical over here, as we can see. And now I will need to adjust this a little bit because the profile will not intersect that well. So I will keep this lower. And I will add a value over here, for example, 200. And we're going to see that profile will go like that. And I will just add that dimension value to 30 again now. If I will leave that and I will reactivate, so I will unsuppress that feature, we're going to see that now on the bottom, this will be parallel with the one on the bottom. And this is what we wanted in this case. Now, we need to join those surfaces. I'm going to use the loft surface. When you are using loft surface, it's important that if I will select a point over here on the top, I should contain the same distance over here. So I will select somewhere over here onto the larger one on the bottom. If I would select something like this, this will give us a twisted loft surface. So this is why it's important to position those points to be on the same area of the circle, let's see. And we can also define the constraints, because if I will just click OK and leave it like this, we don't have tangencies over there, and the model will look a little bit off, as you can see over here, where those two will meet. We don't have any tangencies. So within the surface loft, I will adjust the constraints to be with tangency to face. We see this will be the one on the top. We can adjust the length of this, as you can see, with a value of 2, it will look like this, so it will be a little bit off. I'm going to go with a value of 0.5, and this will maintain that tangency. We can also use the curvature to face option over here. With a value of 2, the model will look like this. So if I will remove that, we're going to see how those surfaces will be merged over there. So they are merged, let's say, visually, because they are not merged together. We need to knit those with knit surface. But we can go with tangency for both in this case, and the profile will look like this. I will do the same over here on the bottom. So if I will rotate, I can do the same loft. The main problem, if I'm gonna click on those, is that I don't really see the, let's say, the preview of this, since it's not that visible. To better visualize this, I'm gonna click over here in order to go within the front view. And now I will just swap the visualization to have the inner. So this will be the last one, wireframe, and this will give me that preview. And we need to add that tangency over here as well. So within start and end constraints, I will add the first tangency. So those two surfaces will be well defined. And over here on the bottom, I can slightly adjust the value. Even for the first one, if I will add 2, this will take the profile a little bit lower. But for the end constraint, if I will add a value of 2, we're going to see how this will go a little bit outwards. So this is what we are looking for. I will leave a value of 2 for the first one, 4 for the second one. I will click OK. I will go back to the visualization, and we're going to have that profile defined. Now, if I will go within a section, we have the geometry over here defined. So we have the main body, afterwards the body on the top, so that handle profile, and that will intersect over here and be continuous. Now, the main problem is that we need to trim over here that self-intersection. So in order to do that, I will leave the sectioning on, and I will go to trim surface, and we're going to use the trimming type to be standard. The trimming tool will be the swept profile of the handle. And within the remove section, I will click over here until that will become pink. And afterwards I can click OK. And we have that profiled trimmed now. We can now start adding over here that thickness. And we have a reminder over here that we should save that work. I will just close this for now. And to get started over here with the thickening, we have the possibility to join all the surfaces together with knit surface. So I will add the swept, the first loft, the main revolve, and the second over here on the bottom. If I will click OK, you're going to see that we still have over here a surface body, which is this one. Within the knit surface, I have the possibility to create a solid. But in this case, we see that SolidWorks will fail to meet those and have this added material on the inside because of the geometry of the Klein bottle. And this is why this is an interesting model. If I will try to add thickness to this one, for example, I will add 3 millimeters. I can go on to, and as we can see over here, if I will go outwards on side 2, if I will click OK, this will be unable to process. And we only have this added over here on the top. If I will go over here on the bottom with the outside, so this mainly because SolidWorks doesn't really know what is the inside and the outside of this model. This is why the Klein bottle is an interesting model. If I will go with the one on the middle, if I will click OK, again, we are not unable to add that thicker. Therefore, in order to help SolidWorks to better understand the inwards and the outwards of the model, within this surface knit, I will have the swept removed, so this one for the handle, I will delete that. I will only leave those of the main body. And now if I will add that thicken over here, for example, I want to add 3 millimeters onto the middle on both sides, I will click OK. If I will go within a section, we're going to see how that added material. And over here, this is the profile that has that thickening. And now we need to overlap it with the one over here. So I will do the same for the swept, thicken 3 millimeters. I can check this merge result because I want the solid model output of the base to be merged with the handle. And as we can see in this case, the surface could not be thickened. Therefore, if I'm going to go over here within thicken, I will add the thicken over here to be on the outwards. Again, we're going to have that problem that this cannot be thickened. Now, let me go over here within the section so we can better visualize this and see what is happening over here. We have that knit surface and we still have a surface over here on the top. So this will be solid, this will be the other one. If I will delete that original thicken and I will add the thicken over here on the handle, I will click OK. And now I will do the reverse. I will add this over here and I will click OK. The same problem will again appear. And this will be because I'm having that merge result. If I will not have those merged, so the first thicken will be over there and the second one will be over here. If I will go within a section, you're going to see what's actually happening over here. So we see how that profile will go. We have the following problem that we don't have that material added over here onto the handle. Well, we actually have that. If I will just, for example, hide the first body over here, within a section it will look like this. If I will display the first one, that will look like this. So we see over here we don't have that perfect overlap, so it will look like this. But over here we have that merging problem between this and that over there. And if I will try to have that merged, we see that this will have the following troubleshooting over here. Now, in this case, we have the possibility to change a little bit the sketches, because, for example, within this bottle that I created previously, you see over here we have a thickening of 3 with merge results over here, and the second will be over here with 3 millimeters. And this worked. I also added a fillet afterwards. So within the section, those two profiles look like this. And the main difference with this one will be regarding the shape of the sweep over here. So I will go over here and I will have this a little bit adjusted. I will change this value. Let's say that I want to increase this to be 250, and this profile will go a little bit outwards. I will leave that, and let's try to merge that again. As you can see, that surface cannot be thickened. Now, another workaround that I could do over here is to, I will delete those thickening, and within the surface, when I did that knitting, I will just recreate it from scratch. So I will start from the bottom. We have that knitted surface. I will add a thickening, and I will go with a slightly less, with 2 millimeters, not 3, onto the middle. And I will do the same over here with 2 millimeters. And as we can see in this case, this worked. Now, if I were to increase this to 3 millimeters, we're going to see that this will be the main problem. If we're going to go with a lower value of 2.5, considering the current geometry, this should also work, but afterwards that 0.5 millimeter will not work. So keep that in mind if you are trying to design this bottle. With 2.5, we see that the overlap over here will work perfectly, and we can start adding the final finishing fillets. So I can use the fillet over here within surface or within feature, and I will add a fillet of 2 millimeters onto that edge over there and the one over here. If I will click OK, this will be the output profile. And now we can also adjust some aspects regarding the visual elements over here. I can make it, for example, red. And if I will expand this, I have the possibility to make this transparent. I will go over here. You will see that the last feature that you created will also define the solid body name. In this case, fillet1, define this one. Therefore, I can click over here on that transparency, and I will have transparency added over here onto everything. If I will just make the last fillet transparent, it will look like this within the viewport. Okay, so this was regarding Klein Bottle design within SolidWorks. We have seen how important it is to keep in mind that some profiles will overlap and will not merge together, but we can fix that by going and adjusting those sketches. Now, the main advantage of this and a model that was created, for example, in Fusion or within CATIA Imagine and Shape, is that this will be parametric. That means I can go within this and I can change the profile of the shape. For example, if I'm gonna make this 60 degrees, and over here I will make this only 250, we see how that profile change. And now if I will leave the sketch, SolidWorks will automatically update the model, so the revolve, which is that extracted section over here. We see how that will be defined. In this case, that still remain the same over here, as we can see. This will be the new line that we have over here with 45. So that profile hasn't been changed, but we can have that reconverted over here. So I should go over here within the surface of the revolve, And as we can see, that will require additional changes. So I can select that point, and I can make those coincident, and that point coincident. And now this will update the bottle. And as we can see, now this will be according to the changes. So keep that in mind, that even though this is parametric, as we set it like this, since that has been converted from the sketch dimension, you should go and make sure that those points will be also exactly onto the new sketch. Okay, so this was SolidWorks. I also created similar videos like this for CATIA. You can find those over here on my channel. So within CATIA, the Klein Bottle design, within part design, and over here I have a different one. And I will also create the same bottle within Fusion, both part design as well as freeform. Okay, so I hope you enjoyed this kind of content. I will position a similar video over here on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.